Hello, everybody. So, welcome back for whatever where we at day 2 of module 7. Um, kind of like the other day, just a couple of things on the list to go over. Um, I just kind of made a list, and the last, well, I guess the last two things that we saw are objectives. We'll look at those. Uh, Navigation meshes or using AI navigation in the games. Uh, It's fairly straightforward and consistent across our different game engines, something we often have. Uh, we'll look at a couple of the functionalities on that. Um, the joints are also in there, but those, yeah, there's three types of joints we have in, and that example will go like really quick because one of them is like a spring, something hanging from a spring, so really easy to visualize. The other one's um, a groove joint group, so things slide next to each other. And then the other one is a pivot or a hinge where it just rotates around a certain spot. There's um, not not a whole lot of complicated uh, issues with just how we connect two rigid bodies to interact with each other. So we'll look at that real quick and text to speech. That'll probably fill up our time, but and there's still so much we haven't seen. We've got lots of odds and ends, but from now through the end of the semester, since this is very much a project-based class, what you probably need is time to work on projects. So probably go about an hour each day for the remaining 3 days, and that way there's plenty of time to work on projects or meet with your groups and things like that. But I guess we can start with the navigation meshes. Start a new project.
So in the thing where we have told one shot rules true slash false.
Set it either true or false. Do you want it to happen one time every time you start it, or does it immediately restart itself? So in your case, it would probably be true. So one shot just runs one time, and then you have to manually start it again. Uh, if it's set to false, uh, then it's just a looping thing. So if it's 3 second timer, after 3 seconds, it starts up. It does the thing and then starts over. Gets ready for the next one. I can't think of a name really quick. I'm just gonna call this project week 7. We'll put all our examples in one thing today because yeah, we can just put them in different scenes. Okay, first off, we need a small scene to work with, so I'm just gonna put a plane with a couple of obstacles that we have to navigate around. Try to get some controls out of the way. There we go. So probably need some ground to walk on. So I'll put a quick static body and just fill that up with plane. There, just a big plane. Bigger than 2x2. So it's good size. I probably could have just copied that world from the other day. Uh, that might have made a good start. And I'll give it something to kind of look like one. solution shape. Go through a little box that's that surrounds the plane. So 25 by 0.1 by 25. That works. Gives us the ground. One obstacles. So we're gonna add another static body. Actually, at this point, it's probably quicker to just copy this one up on the ground. And if I copy that and paste it in, and then drag it over so it has the parent. You just change what the mesh is. So maybe a box that we can't get. Make a box. Sort of like a wall that we have to walk around, and then we'll have the computer figuring out the route. Oh yeah, probably need to. Somewhere the transform on the box. Okay, I'm going to reset that and then move that whole object at once. Good, and that'll be a one. Can you copy another one? Yeah, all right. An obstacle that's in the way, but something that we can still walk over. The prison shape will work for that. We just need to make it wider and longer in one direction so that it is possible to walk over it. It's probably what filling up a large area here. Okay, some sort of little world to walk around with a couple obstacles. Uh, you might want to play with it a little bit more than the very abbreviated version here, try different obstacles and stuff. We'll have probably need a character that we can, two characters, one that we can control, and the other thing's going to try to follow, and then the one that's going to automatically follow. Um, uh, so I'm going to make a character body. And gonna need a some sort of graphics and I believe check. Let me get it up there. We're trying to get those other things colors that will look strange or behave unpredictably when they start moving. Yeah, it took a lot of time when we started. So I started making like setup files, the starter files, that way we don't have to make this every time. So I think by this point, uh, you'll know how the setup works, right? We've done the things we do over and over and over again. So we probably all very long in this tonight. There we go. So we need couple spots to target. Maybe first off, before we add in regular controls, we'll just move this thing around this world. I'm gonna take the player to start with and just kind of choose a couple spots, write down the numbers. So we'll start it in different spots and then maybe go for where it's at right here. So if I take the transform, this looks like a good destination point. 8, 1, -3. Probably 2, 8, 2, -3. So like that's the spot we want to get to, but have to take different routes depending on if we started over here or over here. And yeah, just wherever we're going. I just realized something that capsule might not work at. One of the things we'll look at is the look at feature, and probably won't be able to tell what it's looking at very well from something symmetrical like that. So I'm gonna switch that to a box, something we can actually see spinning. Oh, okay, that way we can actually see which well, we'll be able to see it turn and look different directions. I guess that's the big thing. The material go away, yeah, the material go away. You'll probably notice that if we don't add a material, it sometimes it behaves inconsistently. Make it a great character. There we go. Yeah, so first thing, I'll start here, so it has to walk around that wall in order to get there. So there's a couple parts we need, which obviously when it's not a quick example, probably break that off in its own scene and then bring the whole thing in at once. But if we start searching for navigation, you'll see uh, the navigation agents, and then navigation link, navigation obstacle, navigation region. So our player character is gonna get a navigation, agent. And then our world overall will get the navigation region. And yeah, with the navigation region, just create a new one. Yeah, you can see some of there's different options. How's it splitting things up? Uh, is it looking at, all of the geometry around? Uh, how big of a grid is it gonna break down to? All the things like that. Lots of different options. You can kind of click through and see what the list is and, uh, make sure it's enabled, what layers it on. I was expecting a tab with some options to be over there, but I don't see some of the options I was looking for. So here, with the controls for the agent that walks around this mesh, how high of a step can the agent, go? So, um, if we have a 1 meter tall cube, taking a 1 meter tall step is pretty big. So probably when it, oops, not 1 by 3, 0 meter. Um, how big are the agents considered? Like the radius is going to just buffer zone around it. So in the first case, whenever we set it to walk around that wall, how far around the wall does it walk? Or is it like brushing up against it or leaving a little bit of space? Uh, Probably want to leave a little bit of space, kind of the way we walk around things in the world, and choose that number. Uh, with height is, sorry, height's not the step size. Height is how tall is it? So that's going under stuff. And then the radius is for like walking around stuff. If our characters, we have a human shaped character and it's 1.8 meters tall, uh, we shouldn't be able to walk underneath something that's only, half a meter tall. Then how much can it climb? That's what I was thinking of. How big of a step size can it take? 0.25 means that's like really tall steps. And then the slope that it can go up, um, maybe it can go maybe a 60-degree slope or something. Set all the stuff for that. Uh, yeah, the regions, how's it? What's the smallest, space we can worry about? What's the biggest? Before it has to start splitting up. Um, and just like our meshes, it's going to be a collection of polygons. Once we go to the vertices, edges, and faces, all that stuff together, there's going to be a set of polygons. So how many vertices do we want for each polygon? So it looks like it's set to 6 by default. Triangles would give you your most accurate one, but are obviously going to, take up a lot more RAM. The stuff under details here is just wiggle room. Um, how, how much inaccuracy are we allowing? How much room for error, margin for error are we allowing? So you can, low hanging objects, walkable. It says spots are not walkable if, the max height is within the, Have trouble even reading that sentence. Can we walk underneath the things, over top of things? How does that go? Um, is it like without stepping up? So if it's something that's just like a 2-inch ledge, do we have to go through a big process to step up it and probably switch to animation on our character and all that? Or are we just gonna go right over top of that and wait till we have to, something like a big staircase where we would clearly have the character lifting its legs? That's kind of what the check boxes are for. You, well, like everything, yeah, their sizes. Whenever we have that ready, we make navigation mesh. I was expecting to see some usability though. I don't see any changes, but it would be like a collision shape, which the character has their own collision shape now, doesn't it? That should be a box. There we go. So yeah, kind of like our collision shapes. I was expecting to see some graphics from it, but I don't really see too many. But yeah, it samples our whole world, gives us looks at uh, what we can walk around, walk through, and then most of the setup is with the navigation agent in our code. So I'm going to attach a script to the player. Seems like a good name. Try to make that big enough to see without losing all of the screen space. Couple things we're going to need. Obviously our ready function. And then what is the physics function? Physics process. Oh, gravity to work. And since it's not a rigid body, we'll have to add gravity in. Gravity is, we go project settings. There's get setting. I think there's get setting. And well, it's kind of a long name. Physics / 3D / default gravity. There it is. That'll bring in gravity just like we have around your bodies. That's one of the things that gets removed from character bodies. The project settings that get setting, and then all of the stuff that got removed from a rigid body and a character body is accessible to you coming back on. Or if you then delete the character body script template script like I accidentally did on this computer, that's usually already typed in there. So first thing we want to do is probably make sure the character's staying on the ground. So if not is on floor, we'll just apply the gravity. Velocity in the y direction is going to go down by gravity times delta. All that should look familiar at this point. That's just making sure it falls on the floor. Putting back in one of the things that was removed from rigid body. Now we'll start setting up the navigation mesh. We need a spot to walk to, so I'm going to call it target. We're going to move towards the target. And that's just a spot in the world, so it'll be a vector 3. And then the normal setup syntax for vector 3. And then that spot that I just kind of found, that seemed a good example of we want to go towards something. then afterwards we'll come back and add a second thing where maybe we're chasing the other thing. So 8, 2, -3 is what it was in mine. If your role's set up a little bit different, maybe a different spot, but if you just move your character around, you can find some destination point. Then obviously we'll need a reference to that navigation agent. We can just drag that in. And I'm gonna call that agent. That seems a whole lot easier to type than whatever name they gave it there. Let's see. Target. And yeah, we're gonna want to keep checking where that target's at, because at first it's gonna be stationary, but it's gonna need to keep checking where the target's at and where it's at itself, and then to figure out a route. So I'm gonna make another function. I'll just call it find target. Taking some parameters. What are we trying to find? And we set target position. Agent dot set target position. I don't know why it's not on the but that got updated. I don't know why that wasn't there. Instead of Wednesday, it got updated in 4.4, and I'm apparently looking at an old example. Instead of using the function, we'll just access the variable directly. So the agent has this target position variable. Where's it trying to get to? And that is going to be the position of the thing we typed in. Or just the point we're trying to get to. Our target is already set as a vector 3. So if we were looking at like another character, we would just pass in the position of that other character. But where are we trying to get to? I would accidentally bookmark that. I have no idea what key I bumped to put a bookmark there. But seems like it can be really, really useful, but I'll pay attention to which key actually. We have the target. Well, that's what we're gonna do. First thing we're gonna do is we call that target and pass in our target value. Pass in the value of the thing we're looking for. And then we probably want to stop eventually, right? If we don't want to run into the thing. So a good example might be if our game's set up where there's like multiple playable characters and they're all kind of walking together. You're just going to be controlling one of them and the others will follow. But you don't want them to constantly run into the one. So we would probably stop a little bit away from the target. So you just choose a number. So like if the player's position distance to the target that we're looking for. And then just set up some threshold. More Two, it's probably good. It'll get close to that spot, but not right up on it. Might need to be more than one or more than half, depending on the situation, what that looks like. And now we just need to take our figure out where we currently are and where we want to be next. Like, where should we be at in the next frame? And those two things tell us where to move next. When we see the function name for well, I'll go ahead and say it. The next spot we want to be at, I'll take that first. Where do we want to go next? The next spot or position. I'll do spot, that's easier to type. The next spot is going to be the agent dot get next path position. Hopefully that makes a lot more sense than the sentence I just stumbled around on. So from where right now, where's the next spot we need to be to eventually get to that target we're heading towards? In case of walking around the wall, we'll have to walk the length of the wall and then come around the wall and come back the length of the wall to get around it. And we need to so that tells us the vector 3, the point in space where we need to be next. And when we take that and compare it to the spot we're currently at, between those, if we subtract those two, there's going to be it'll give us a vector that points between the two. So current spot, and for that, if we just grab position, it's going to use the character's local position, local coordinates, and those are going to turn constantly because here in a moment we'll use the look at function so that the character is always looking at the spot it wants to go. So the local coordinates won't match the global coordinates, and the AI agent is always going to use global coordinates. So to get the global coordinates, it's just global transform .org. So really, that's where are we at with respect to the it's not a function. Sorry, just a variable. Where are we at with respect to the origin of the global coordinates? Right, that spot we're trying to get to, I move the character around and then just check the position. So that was the global, that's that spot we have in terms of global coordinates relative to the original origin. And then we can use that to make a direction. Which if we maybe a quick picture. So like in 2D, since that's just so much easier to draw on a board, if one thing is like this, and maybe the next one's here, when we subtract them, all of that part comes off, and what we're left with after we subtract them is just that line between them. If that picture helps a little. Yeah, so when we subtract this off of this one, we just have that little bit of overspot plus how much it went up. So we're left with just the vector between them. So subtracting it's going to pull subtracting this one is going to pull all of that spot away. And Then when we subtract this one off, it's gonna pull everything below that off that other vector. So what we're left with is from where those, this little right triangle here that describes the distance between those two. So all we have to do is subtract them. It's probably, yeah, I wanted to do a picture or something because it's not very intuitive. Not very intuitive why subtracting two vectors gives us the vector that points between them. Seems like there'd be something, a different result, but that's what we end up with. So the spot we want to end up at, like always, the newer number goes first. Anytime we're looking at a change. So the next one will be our newer number, and then we'll subtract off the older number. So next spot minus current spot. Gives us a vector, a direction to go in, but we probably control our speed differently, right? We have some speed set in, so we want that normalized function so that whatever vector we end up with, we just divide off the length so that we have a vector of length 1. So it's just telling us which direction to go in. It's not impacting our speed. Yeah, then we can just change our velocity based off that. Velocity.x is going to be direction dot x times speed. Come back and figure out what the speed variable is. And our y velocity, not y, sorry, our z velocity, since we're doing a 3D one, is going to be it's going to be the y direction from that other variable. The way it's measuring, it's we have x, y, and z, and the way this just calculated what that's going to be. It did the calculation as if z was the up down axis. What would normally be our up down axis. So we do have to change that to y here. Direction dot y times speed. And then we should probably come up with a speed value. For variable speed. Floating point number. I'm just going to guess 5. We'll see what that looks like, and might need to make that a lot faster, a lot slower. Does all of that look somewhat familiar? Once we get down here, that changing the coordinates is a rather strange thing that happened there, but it's because we're measuring differently than we normally would when we move our characters around. But it's something that like always happens with navigation meshes. So just remember that once you find your direction, the y becomes the z value, and the z value becomes the y with the navigation agent. And then we need our move and slide function so that all of the movements do something. So we'll figure out where it is we need to go. Gravity will pull it down if it's not sitting on the ground. Then we look at where we need to get. Where's the next spot we need to get to in order to get to that destination? Where are we currently at? When we subtract those, we end up with a vector that points there, except y and z get swapped. Which seems like a lot of steps, but that's the only changes. Oops, that's only missing. Yeah, call it that. Oh, probably need a camera if we can see something now. Oops. Something went very wrong. There should at least be a collision shape on the ground. Need a collision shape. Oh, I changed the wrong one somewhere in there. This should be 25.0.2 by 25. This one, the wall has the wrong collision shape. I think it was 7 by 1. Yeah. Okay, I think it's right around it. With it being blue, I couldn't tell if it was same color or not. Let's see if the character actually goes down. Does the character have a collision shape? Yeah. Okay, let's just change that. Okay, I don't know why that's happening. Apparently copying and pasting was a bad idea. Because now it's if I change one, it changes all of them. I don't think I've encountered that before. 21 by 25. Then if I go down the wall, make a new collision shape. 7 by 1 by 1. That changed first. Okay. That seems like a bug. I haven't encountered that before, but if you make a copy of something, it should probably should probably be a separate copy. I guess the technical terms would be shallow or deep copy. It made a shallow copy instead of a deep copy, so it was still referencing the same box. Um, did a nice one. Well, you might have any thoughts? Feel free to share. These are we're reaching in there. And look at what all of them do. So, if we have multiple regions to walk on, this is like building a bridge between them. Or an obstacle used to affect navigation by spaking or constrain velocities. So what's getting on? So we will need some of that. I was gonna come back and do that, but I'm gonna put those on there. So, the wall here, put try to make that a navigation obstacle. No, see different options, affect navigation or change what it's doing. If you want to manually code everything, it should just get picked up by our navigation mesh. I need to make that like go with the graph. Did I change anything here? Yeah, this is- Well, that's probably why I'm not getting the preview like I was expecting earlier. It's enabled. Turn off edge connects. On that layer, yeah. Very good. Something here. Yeah, the look at. So we can always just use this look at target. So I just want to see if that's, make sure the script is running. Make sure it's doing something. So it did turn. That's not the player's position, is it? 6-1. Yeah, so the player has to move to get to that spot. Sorry, is it just like an incredibly low speed or something? Oh, I'll pull up documents. I'll make sure I don't forget anything. Navigation, region. Using navigation features. Okay, it's not very helpful. And then this is just the box, right? Okay, so documentation is not very helpful. I apparently skipped a setting, and I'm not sure which setting I skipped. That's selected. Unless it's a setting here. That was only good. I apologize. I'm not sure. I what I messed up on. Maybe if I delete that region and make a new one because I obviously did something to it. Navigation region. What's the warning say? Reset or created for this node to work. For the mesh, I'm just gonna. Disconnect. So, create a new one. And then once we do it, get all the settings set. Pick the navigation mesh. And I was really expecting to see some visualization change there. I hope I didn't use the wrong version of Godot when I was getting set up. Let me check for bugs. There ain't no bugs. Engine 3D not baking in Godot 4. And I have my parent-child relationship backwards. Does that sentence make sense? By default, the navigation, it parses all its child nodes, but I put this as a sibling of that. So let me collapse that. So everything we want to walk on or around needs to be a child of this. Okay. There we go. And then it's like this and bake it. Okay, now we get visual cues. Is that coming through okay on the camera? Sometimes the camera doesn't do it real clear, but see how there's like a little buffer zone around the wall? That's the radius that when kind of the edge. We can walk over and around stuff. So we went around the wall. Okay, 50 is way too fast. Let me go adjust that script back to what it originally was. 5. I'm gonna change this to a 1 because it's about to fall off the edge there. It goes and finds its own route. Okay, 5 is way too slow. Still walking around the wall, and if we start from different positions, or we move that wall. So we can't go around that way. And take our clear. Over here or something. Keep it in the room. But notice what it did. Any thoughts on why it did that? Oh, I didn't notice Clayton's in the. Somebody was sitting in the waiting room and I didn't even notice the thing. Hi Clayton, I just now saw you in the waiting room. It was not up, it didn't make any sound or show up on the screen. I apologize if it's been a minute. Any thoughts on why it still took the same path when the wall was in a different spot? If I zoom in here, we might be able to see it. See what the navigation mesh is still for the original position of the wall. So it doesn't update automatically. Anytime you make a change, you have to come through there and rebake the mesh. Now it should walk around it. Okay, that speed is like way too slow. It's confusing the thing. Script. Let's go with like 25. And this often happens with it. This is something you'll encounter. It has that little bit of radius around that when we saw that setting, but for some reason, it's still our character's getting caught on there, so probably need a bigger radius. That's under the navigation mesh. Geometry. Oh, geometry. Pages. 0.5 is not enough, so we add 2, and then rebake our mesh. That gives us a much bigger area to walk around. Well, 2 is probably too big. Let's try 1. Like that. From looking at that, I'm feeling it might still get caught because it's going to try. Oh, there it goes. It tried to turn and look at when it tries to turn and look at it, it those are all off. Go make the script, make this. And that gravity pulling it down at the start is adding a whole lot of speed to it. That's kind of what's going on, why it's going so fast at first. Moving downward, it's not gonna. Not gonna pick up speed before he hits the ground. Just give the regular speed and move over slowly, walking towards that spot. Turning because it always wants to face it, whichever way the computer thinks is the front of the box is always going to turn and keep looking at that thing. So you can see there's just a couple of steps. And then if we were to say, start over here. And try to get to that same spot, it'll figure out the closest route is over the box unless it just falls off the ramp. I don't know why it did that. Let me turn the speed back down. Okay, that's just something weird going on. Where's that's why. Um, so notice that the navigation mesh is not a collision. So when we copied and pasted earlier, I still have that box collision on that on the prism shape. So it just has the shape of the wall under this. So instead of that's why I was passing right through it. Actually, it has the shape of a capsule. We can do prism shape. Or let's just do this. I'll delete that one. And then just use this to create a collision shape that fits tightly to it. Nothing was moved, but now it should be able to, thing should stand on top of it. There we go. Walk over the ramp and get to the spot. Choose weird directions. You can play around with them a little bit. Really, it's just a couple of those couple lines. So find the target you're looking at. I was expecting to be here about 5 minutes ago and was going to do some other stuff, but the other stuff I had in mind for like the last 15 minutes might not work. So figure out what you're looking at. It could be another character. Then you'll want to keep set up a function so that your agent will look at that thing, which is just agent.target position. So you could set it, could just do that over and over again. Yeah, I'm gonna do that. I'm gonna make another character. Maybe I can abbreviate it. I was thinking it was gonna take 15 minutes, but maybe I can abbreviate something down to like 5 minutes and do it really quick. So I'm gonna create a new player object, and then we'll have this box just follow the other player object around. So create a new child, character body. This is gonna move. Give that some sort of shape. Maybe a capsule. Give it a color. We yellow. And we'll give it a collision. Which I call the will match the one water. We can snap off so we can leave it just above the ground. That way when in the first frame, it'll fall down and stand on the ground. And then we just need to move it. Yeah. I was originally thinking 15 minutes to set up the character script, but if we just do like a positional change instead, just make our buttons change the position. So function. I guess we can run it real quick. So the physics process, and we need an X variable. And the Z variable. And if input is action pressed UI pass, and then I'm going to copy all this. Copy the up, down, copy that, and left, right. So if we press up or down, we want our Z to move. We want something happening in the Z direction, either forward or backward. And I'll just move this left or right. So we'll set those up, and then we can create a new direction for it to go in. Direction. Variable is direction. That's going to be a vector 3. And we do transform.basis. That gives the direction we're facing. Actually, I can probably skip that. Let's just put a vector. I think this will work. We'll just put a vector in there that is whatever we found for X and whatever we found for Z. And then we can set our velocity the same way as we did last time. Velocity.x is direction.x. Actually, we don't even need a direction, do we? Kind of odd to have that in there. We'll set that as our X times speed times delta, which speed doesn't exist yet. We'll get that in a second. Velocity.y dot z is going to be z times speed times delta. So if we're not pressing the key, x and z are 0. So then when we multiply by 0, all that, nothing's going to change. And depending on the key press, we either have a 1 or a -1. So really the 0 or 1 is, we either have something here or we don't, is kind of another constant thing. And then probably slide on. So things actually happen. Create speed. Speed is and set the following one to 10. So I want the character to move a little bit quicker. So that it has to catch up. Okay, that didn't only take 5 minutes. I'm not sure why that took 15 minutes when I was getting ready. I might have stepped away and did something else that day. Oh, whoops. Don't protect the movement. So we move very slow. It was going to be slow. So there, so we can very, very slowly. We have to dig through the script and figure out why the speeds are so different. Because the other one has a speed of like 10, I think. And it's zipping around all over the place. But as this moves around, then I think her name completely wrong. We can get a reference to that in the well, it was called Player, but the one with the AI navigation. Um, I'll call it controlled here. To get a reference to our control character. And we want this one to be following that, which I'm going to slow this down a lot. See if I work for that. And along with looking at it, we probably want to make sure we're always looking at finding it. This is a very abbreviated example. In an actual game, I would probably set up some stuff so that that didn't happen every frame of the game. Right? If if one character is following another one, we don't need to update that every frame, every 2 or 3 seconds, and that way one of the characters aren't doing the exact same thing. Enough time for like the one that's following to drift off and do something else occasionally, if that makes sense. Whoops. And I put in the character, but we just want the position from the character. That would be the little oversight there. Earlier it worked as well. We had was vector 3, but here, what? I don't know. Evaluating from the key target position. Oh, gotta do that every time, I guess. If you fix something, you have to fix the bug in every spot it shows up. Typical debugging things, right? So now it's trying to get over to this character. So when I start moving, it should follow me. It's not doing a very good job following me. I'm not sure where I got off. Move faster again. So I'm gonna check where it's at. Probably find out. Or look at it. Oh, that's why. This number probably needs to be a lot smaller here. Because 2 meters is quite a bit. That's like over 6 feet. So there we go. No idea why it did that. That seemed like a really big bug, and we're running out of time to try and fix that. But does the idea there make sense? And you can see, well, like always, well, if we just pull up our predictive text, we can see all of the stuff in there. Are we avoiding stuff, layers, layer mask, stuff about debugging, check the distance to target. I guess we already use that one. Avoidance layers. It sets up a path, so we can keep checking that path over and over and over again. But you can look through the list, see what each one does. They're fairly straightforward. Yeah, really this right here, when we find the direction to the target. Oh, that might have been why there was stuff. Let me try this to see if that's why it went the wrong switch. Switch those around. Yeah, the only tricky part is that whenever we find the direction, oh, no, that wasn't it. The X and, or sorry, not X's, Y and Z switch. So our Z velocity needs to be in the Y direction and our X is still X, and the gravity handles the Y. And it's a, yeah, long explanation on why that happens. But just a couple of lines to get those things moving. This should probably be down here. Then we notice that once I've got a certain distance away, then it started following very, very slowly. You can work in those numbers, adjust the speed, how far away it needs to be. 0.2. Probably get a little bit closer this time, and then that should be it. So when it's within that range, it's not going to do anything. But once it gets outside of that range, then it'll start following. And it's not very intelligent, so it'll walk right off the edge of the world. It's just all there. That's the basic idea of it. One of the requirements for the one of your upcoming projects, can't remember if it's on the final or the group project, but hopefully a fairly small thing to implement. It's just a couple lines of code to get it set up, and then make sure most everything is already built into the navigation mesh. So all we have to do is tell it what to look at, tell it where it's going, and then the thing will figure out its own route to the world. But you might have to make some little adjustments to your world to make sure it doesn't do just weird things like you saw there at the end when it just walked off the edge of the world, or it got to the top of the ramp and then decided that was a good place to stop and loses track of where it's going. So small tweaks to make with those, but it shouldn't be too bad. If anybody has trouble while you're trying to implement that in whichever project it needs to go in, just reach out. Pretty much from now to the end of the semester, I will be around to help if you need it. I've large most of the stuff that's had me busy lately is all wrapping up. So all the meetings and stuff are starting to wrap up. My calendar's a lot emptier than it has been for the past couple weeks. So except for the graduation ceremony next week, my calendar is fairly empty. And so if you have past due projects you need to catch up on, or current projects you might get stuck on, anything you need help for, just reach out. I can hop on the Zoom call. I have lots and lots of time available to hop on a Zoom call. I still have a few meetings occasionally, but, this time of semester, I will try to keep my schedule open, especially on weekends. So weekends, I'll pretty much be around to hop on a Zoom call immediately. Otherwise, it won't be very long until I do, so that if you need help, we can do that. Otherwise, do y'all want to meet with your groups and breakout rooms for today? I guess I can stop the Zoom call and then, see if you want to do that.